It's my task again to introduce, in fact, the last speaker of today, who is Professor Jan Honza Černocký from the Brno Technical University. He's the head of the speech lab at the Faculty of Information Sciences. He was heading the lab for very, very long time and has established the group at that school, who is now probably the best speech-oriented group in the country. Honza has also a lot of international experience and also an international team with many or several of the top scientists in the country in terms of not only speech and language processing but computer science in general. So, Honza, please.
So thank you very much. I have this bad role of the last speaker. That is the only obstacle between you and the dinner or going home. So I try to be as entertaining as I can. Actually, thanks Jan for introduction, and just to mention the French connection I have. Actually, I was first in France for my diploma thesis. At that time, I didn't speak any French, or almost. But then I somehow started to like it, so I did the DEA and thèse en co-tutelle at the University of Orsay, Paris Sud, and it was quite a complicated arrangement. We actually had the first European project thanks to French partners. At that time, Matra Nortel was the key industrial player in speech industry, and we had a European project thanks to these guys. Then there was quite a long pause, but now we are happy to be together with French people again in Marie Curie Esperanto project. So today I will speak about why I think we are not done with speech recognition. Just to motivate this talk, speech is something that is distinguishing us from the animals, right? The animals produce sounds. We also produce sounds, but our sounds are speech. So I think this is the differentiator. The speech is with us from the birth until the coffin. And speech can serve lots of various reasons. You can express love with speech, you can have a scientific conference, and you can also manipulate the masses if you are a good speaker. So that was for the motivation part. And now, first, some entertaining notes about why I think Czechia is a superpower in speech, and then some serious notes about speech recognition and speech processing and data mining in general. So, if you look at Czechia, we almost don't find it on the map, right? It's quite hard to find it. It's just this small country in the middle of nowhere. Concerning economy, we are pretty bad as well. Concerning the military power, we are completely done because we have just 123 tanks, not sure in any usable shape, so we probably are not able to defend ourselves militarily. But we are the superpower in speech processing. So my personal notes on why I think that's this and how we can prove it. So the proof is already the number of really successful academic groups. There are at least a couple of universities that have quite a renommee at the international level. But what is even more important is this map that was already shown by Josef in the morning. I think actually the uptake of the research results in Czechia is quite impressive, and we have lots of companies doing speech and NLP ranging from the like subsidiaries of big international companies until these two-man startups, you know, that are created and that try to do something. So why I think this is the case? Well, the first is our dear language, because actually it was almost lost in the Middle Ages and it was artificially recreated by scientists. And these scientists put so terrible rules into it that every Czech speaker is actually trained in almost formal aspects of speech and language. So just to threaten our French friends, this is the declination of François Yvon in all 7 cases. Then it continues until nowadays, because the poor kids in the 3rd grade, they are tortured with this. So everyone, I think, went through this, and we are forced to do this lexical and morphological analysis from the very young age. And the third thing is that I think Czechs have quite some musical ears. So if you look at any ranking of the classical music composers, there would be definitely some Czech guys. And there was even Leoš Janáček, like my favorite composer from my city, that used spontaneous speech to write music, and he actually got world famous for this. So that was the entertaining part. Now, switching to the more serious one, already in our field, we have some notable personalities. So Jan already mentioned Frederick Jelinek, the godfather of the whole statistical speech and language processing. Then came Hinek Hermanský, that actually started to investigate the links between the machine and the human hearing and the speech production. But we also have some young guys. So Petr Schwarz, for example, my colleague, is the author of the first usable and widely distributed phoneme recognizer, and also as already the chairman of Phonexia, of the first neural speaker identification system. Then our famous graduate Tomáš Mikolov, who actually was around 2010 behind this neural revolution in speech and natural language processing, and also some young guys. So this girl you probably don't know, Kačka Žmolíková, is our freshly graduated PhD student, and she's excellent in signal processing coupled with neural technologies for source separation and target speaker extraction. So now, going to the main topic of my talk, is it really over? Well, this is what we can do with some reasonably long and clean recordings. Actually, the speech technologies already work pretty well. We can transcribe speech with quite a good word error rate. If it comes to person identification, we can do it very precisely, actually better than humans. For unknown voices, you probably recognize very well your mother, but if someone presents you two voice samples in Pashto, you would have really problems to determine whether this is the same person or not. Spoken language is also quite reliable. We can define very precisely or detect the gender, a little bit less precisely the age, and we can have all range of voice assistants having a conversation with you on various topics. So basically, very often I hear, Honza, is it over what you are doing? Shouldn't you switch to something else? And it could seem like this when with all these voice assistants that now you have on every cell phone and in every car with the machine translation that is reasonably good, also thanks to our Prague colleagues. But I still think this is okay for some applications and for some scenarios, but more is needed. So what is this more? There are some obvious open problems. The first, as we already heard from the previous speakers, is the multilinguality. So there are several thousands of languages, and obviously the commercial speech recognition engines support just maybe 100 for the countries that are so fortunate that there is economic power or some good scientists that push for the resources, or maybe both. At the same time, there is a need to develop at least somehow functioning automatic speech recognition for these less fortunate languages, and we should do this with minimum standard resources. So what are we doing? We actually try to mimic human language learning. So we actually crawl data from wherever we can. That's what we heard from Benoit and also from François. We try to take user-contributed annotations from wherever we can, from subtitles, YouTube notes, and so on. And we also try to train the artificial neural networks on well-represented languages and adapt these schemes to the low-resource ones. The second issue that is not solved at all is the robustness. So we are quite successful in developing some systems for the clean office or home conditions. But when it comes to some difficult channels, for example, to the military ones, but even if you want to look at the civilian domain, if you are in a car that is running in a rain with the wipers running, this is actually pretty bad signal. And the current technologies have quite some problems with it. So we need to tackle the robustness. Of course, we would like to use the hot data, but no one gives them to us. So we do quite some work on augmenting the data, adding noise, distortion, reverberation as in this room, making the neural nets more robust by applying some severe tricks on them, exploring the uncertainty, where the goal is not to do a perfect recognition system, but to do a recognition system that would tell me, I don't know, I have no idea, you should not trust me. That's a problem with nowadays, not just speech recognition, but artificial intelligence in general. And we also try to work with some unknown events. For us, speech guys, this is mainly the out-of-vocabulary words that are popping up every day in the official and unofficial language, both. So the third thing is the far-field microphones. Again, developing something working for a close talk, nice speech is relatively doable. But when it comes to remote capture of speech by far-field microphones, for example, in a room like this with lots of reverberation, it's a problem. So the first thing is to get this reverberated and far-field data at all. Here, again, no one ever gives us hot data, so we simulate or we re-record standard speech corpora in different rooms. And then we need to do something. So either we do some standalone neural network-based signal pre-processing, or if we have the chance and have multiple microphones, we can do some sort of beamforming that would steer the acoustic beam to the particular speaker. We can do this also in an informed way. So if you have a sample of the target speaker, we can actually inform the extraction neural net of that particular speaker, and it will be more happy, and the system will be more reliable. And of course, the ultimate thing is to do the whole thing as end-to-end fashion, because all the signal processing blocks, like for example correlation or fast Fourier transform, they can be described as layers of neural networks, and they can be trained. And it works better than if one does it separately. So these were the obvious things, but there are also some hidden technologies that are quite crucial to what we are doing. The first is this good old voice activity detection, like determining whether there is speech at all in a signal. Well, you could say, hey, Honzo, why are you speaking about that at an AI seminar? This is easy. Any student can write this on 10 or maybe less lines of Python code. Yes, for clean signals. If you come to anything that is noisy, that comes from a real like a vehicle or military environment, this is actually quite a tough task and requires quite complex training on lots of data, eventually supported by some quality measures. The second non-obvious thing is speaker diarization. This is something when you have multiple people speaking in one channel, is to say when a speaker A spoke and when a speaker B spoke. This is, again, very easy if you have clean stuff and the people are not overlapping and they are nice to each other. But once it comes to some realistic scenario, the classical like segmentation and clustering approaches don't work at all. And here we start to feel the need of having the context, not only like who speaks, but also what the speech is about. Because only if we have the context, we can put it together to create some reliable diarization. So this is, for example, the topic of Mireia Diaz-Sanchez, our senior researcher, Expro research project proposal. So if the reviewer is here, please give her good marks so that she gets the funding for this proposal. Okay, then I'm switching from speech to some general challenges. The first is to come up with some annotated or transcribed training data. Usually we basically need speech that has associated text. Well, for some languages and for many scenarios, the situation is that we have plenty of audio, we have plenty of text, but we don't have the link in between the two. So to fight with this, we are working on techniques that allow to have, I call it a vicious circle of text-to-speech synthesis and of recognition, and basically we can feed it from one side by speech, recognize it, synthesize, and see whether it matches the original speech, or to do it the other way around in so-called cycle-consistent scheme, and it does something. The second thing is the pre-trained models. So I think François and Benoit already spoke about them, and I dared to create some, well, not very amateurish schemes. This is how it looked like 15 years back. Basically, you had this newest and very advanced Gaussian model, and to produce the world's best results, you needed lots of math, thinking, programming, some data, some computers. Now, 10 years back, with the neural nets, that was pretty much the same, only the basic block was replaced by these very top advanced neural network-based algorithm, and you needed more data and more computers. Some 5 years back, the situation started to change a little bit because people started to use lots of out-of-domain data, and then for the target task, smaller and smaller amounts of data were necessary, and this started to work as well. And now we are in 2022, where basically we have the situation with the big pre-trained models that were done, especially by these big players like Meta or Google or others, that saw so much data that we researchers can never put our hands on, that were trained on so many GPUs that basically just the energy footprint is costing several thousands of, hundreds of thousands of dollars. And this is how we need to do research these days. These models can be basically used for many things. And this is not just my impression, there is the whole challenge. It's superb running in the speech area, but there are others running in the NLP. And it seems that whoever does not have these big pre-trained models simply has worse results than in the past. So what to do with them? I think there are several approaches. For me to improve them and fine-tune them is okay. Use them as feature generators, as very good representative power is okay. Combine, fuse them with some other schemes is okay. Even criticizing them and refusing them is okay, because some people say, well, you know, these are proprietary, so we need something lighter, own, better, license-free. This is fine as well. But definitely, I think it's not okay to ignore them and still stick in the old world, like pretending that they don't exist. So, if you ask me if there is a time for retirement for the speech guys, I think the conclusion is that there is no time for retirement. And I'm almost at the conclusion. So this is a plea for support. Please, if there are some people that like our speech and NLP guys, stop claiming that it's done. I'm just comparing it to the drug research, cancer drug research. Every week we can read about some new like a cure, procedure, or maybe drug, but no one ever dares to claim that it's over. That's the same for speech and language. I would like people, and especially our European representation, to consider the speech and NLP as key areas for Europe's success, and also accordingly define some support lines in Horizon Europe, EDF, and others. The other 2 points is that I think there was so much, and the concentration of power is so big on the US side, is that we simply cannot ignore them and cannot claim that there will be like self-sufficiency of Europe. So I'm a proponent of cooperation. And the last thing is that we really need some flexible schemes to work with the data so that they are useful for training AI models. I think actually we should not be blamed for copying the data and selling them to someone, but for training something useful on this data. That's it. Thank you for your attention, and I'm taking questions.